Well, hi everyone. Thanks for joining today, and thanks for everyone who is looking as well. So, my name is Ioannis Papaioannou. I'm the CTO and co-founder of Alana AI, and today we'll be discussing about this mystical phenomenon, this large language models, right? Which I'm sure that everyone has heard about, ChatGPT going on the news right now and everything else, but also, is it actually the solution? Is it the end of AI? Is it like going to take over the world? And all of these things that we actually have in our heads and being circulating around the news nowadays. So first of all, just to demystify, what are large language models, right? There are simply deep learning algorithms that are trained on vast amount of data, trained to imitate language, and they're doing so by learning the patterns and structure of language, right? And then they can be used in downstream tasks such as text generation, text summarization, question answering, and any other downstream task that we might have. And although conversational AI, as it's called, like this field of AI, holds a great promise in the industry today, like covering from a conversational search of information to a conversational assistance to assistance like for the elderly in the house, but they still have a very crucial point and place in the industry. And in order to use them properly, this system needs to be safe, faithful, they need to be highly controllable, and they need to be robust to miscommunication because it's a language interface, it's a voice interface. And even as very large language models, such as GPT-3, for example, and GPT-3 has shaken the world, these models are still very prone to failures. So in order to use them properly, we also need to make them adaptive. The input needs to be dynamic. We need to have additional modalities. The output needs to be repairable, and they need to be explainable as well, because large language model effectively are like black boxes of input-output, right? Just a very brief introduction, like who we are and what we do. We are an official spin-out company from Heriot-Watt University here in Edinburgh, and we are very heavily involved in research and R&D. And what we are doing is that we are trying to harness the power of large language models and conversational AI to apply them to real-life scenarios in a safer, more controllable manner, right? And as a spin-out, we are uniquely positioned between research and industry. Our primary focus domain currently is healthcare and blind and partially sighted people. Now, I'm talking a lot about dialogue, right? Why is it so important, right? Well, first of all, it's the next evolution of user interface, right? When back in the 70s, 80s, we were only interacting with computers using console-like systems like MS-DOS or BSDs, and then suddenly we had Windows, right? And we had a cursor that we could move around and click on things, and it was wonderful. Obviously, this system started evolving even further and becoming more intuitive and easier to use, right? And it revolutionized that. And then suddenly we had smartphones. Suddenly you can use your finger to do things, right? And completely revolutionize the way we could actually interact with the phones. And in most recent years, we have the Alexas and Siris and voice assistants of this world, where we can actually use direct language to interact with these. And this type of evolution actually opens up a lot of options for us, including accessibility options for users, right? Things that previously excluded a lot of large groups of population. Now, this also opens up a lot of different and unique challenges, which I promise that I won't go technical in this specific presentation, but just wanted to mention a few honorary sticking points. Like, these challenges of conversational AI include various different linguistic phenomena that naturally occur and emerge as we talk, right? Ethics and abuse from the user, for example, to the system. There's huge research going on specifically about that. clarification. There is a lot of ambiguity in language, right? You're going to say, oh, can you pass me the cup? You mean the one on the table or the one on the chair, for whatever reason, right? So there's a lot of ambiguity in language that needs this sort of clarification exchange between a system and the user. And then obviously we need to be consistent in the responses, which is something, for example, that large language models kind of falter, and we'll talk about it later. They need to be safe, which is one of the biggest hurdles right now when it comes to conversational AI, right? They're wonderful in what they generate, but they might not be safe. And of course, the issue of privacy. And all of these problems stem from the fact that language has evolved to the state that it is today through thousands of years of us communicating. Especially myself as a non-native, I'm actually doing a lot of hand gesture, right? Non-verbal communication. All of that, although you are very perceptive and you understand exactly what I'm trying to say to an artificial intelligence system, all of that is still very, very challenging. Let's have a look at the current state of the market, right? So we have many different systems right now. Obviously, you've heard about, as I said, OpenAI, ChatGPT and GPT-3. Now we have the counterpart from Google called Bard. We have Bloom, which is a large language model used heavily in research and academia. It is open source as well. And of course, at least we forget what started all of this with Elmo and Bert, for example, transformer-based models. And yes, these are real names of models. And all of that creates a blooming market that is supposed to expand to $110 billion by 2013. So you see, it's just exploded over the years exponentially. However, large language models, as I said, are trained partly to give convincing answers, right? But these answers can be unfaithful or just untrue, right? And inevitably, some people are trying to rely on these responses with potentially catastrophic consequences, right? And this is one of the main reasons why we haven't seen such a huge industry adaptation on large language models yet. Because apart from that initial wow effect that these systems have, often the responses can be either very boring, for example, or they can be extremely inappropriate. That's been a constant challenge on how to control these systems to be appropriate. I'm not talking just about obscenities here, by the way. Right? Appropriateness can be very context dependent, very cultural dependent. And then obviously inconsistent, as I said before. If you ask several large language models at the moment the same question, you might actually receive different answers, because all they learn is basically statistically to produce the next word in a sequence, right? That's all they do. It's the word largest autocorrect, if you want, right? So this also creates the issue of faithfulness and hallucinations, which I'm sure that many of you must have heard on the news recently. And let's do a quick test here. So if you have a question, when will the new Dunkirk film be released on DVD? And you had an agent presenting these three options. Quick show of hands. Which one would select, for example, would believe the first one? None of you? Pretty believable, right? Or the second one, or the third one. Surprisingly enough, well, not really surprising, we understand why, but our own experiments also show that indeed users preferred the more verbose response, right? However, among the three, it was the only one that was unfaithful. So that creates a false sense of trust of the user toward the system. And unless we control that, we can really use them effectively so people to actually trust them and be in the industry for customer service, for example, for people that require information about something. And this is what is called a hallucination, right? And currently, for example, ChatGPT's hallucination rate is between 15 and 21% of generated responses, which is still a huge problem, right? These hallucinations can either be, for example, intrinsic, which means that You have your model. You have some source documents that are fed into the model. It could be your company's HR documents, for example, or medical records or whatever. And the model could manipulate the information found in those documents to create counterfactual information, right? Or it could be completely extrinsic, which means that it introduces information not grounded in the source document, not found anywhere in the source document, which can either be correct because it's based on the world knowledge, but not relevant to what the user is saying, or it could be completely counterfactual and made up, right? And one of the things, for example, that we do at Alana is analyzing the output to understand why the model produced that response, and if it's not up to standards, repair it, right? So that's one of the main things that we're working. And these, by the way, as I mentioned so far, are all part of the generation part of a system, right? To generate the output. Another point to consider is that when people speak naturally, they often hesitate, they repair, they correct themselves, they make pauses, right? And this is because language is very spontaneous, live language, and it happens in real time. But currently, when we're using, for example, the virtual assistants in your house, right? People need to preemptively think what they want to say and say it in one go, without hesitation, without pauses, and most importantly, without any failures, right? Otherwise, they need to restart. And like, to give you an example, you might ask a system to set a timer, and you say 15. It said, oh, 50 minutes starting now. No, I meant 15, right? This is something, for example, that happens with me all the time. And in particular, for example, at Alana, a few things that we're looking is to unpack and understand these linguistic phenomena that, as I said, naturally occur in human language, and actually take care of them and repair them, right, to put them in the context. For example, you might have pronoun resolution. When was he born means when was Albert Einstein, for example, born. We were talking about Albert Einstein. Or fragment resolution, like the user suddenly says yes. Yes refers to a previous question potentially in the context, which you unpack into yes, I want to hear more, for example. Self-corrections are one of the most important things and most frequently occurring in natural language. Like, who was Alfred? Sorry, I meant Albert Einstein. Especially when it comes to spoken language, not so much in text input, for example, with a chatbot, but with spoken language, it's a very, very naturally occurring phenomenon. Disfluencies is, for example, what I'm doing all the time again. Lots of M's and ums. You might have repetition of the same word over and over again, particularly in healthcare. We're working also on project with stroke patients where these disfluencies are very apparent in their speech. And all of these needs to be understood and potentially repaired before we generate an output of these large language models. And obviously clarifications, right? Let's say that the user asks about a particular product, right? And you might have 2 hits in your database. You actually need to start collaborating with the user to actually ground what the user really wants. Most of the time, it's not like a one-off thing. Oh, the user said this, I'm going to say that, right? It's a bit more complicated with language. And we're tackling with this, as I said, in a more controllable and inspectable way. Now, and I forgot late corrections, which is actually extremely important as well, which goes hand in hand with clarifications, right? If, for example, a system doesn't clarify, and I'm asking, where is Mount Everest? And Alana said, oh, okay, yes, it's in the Himalayas. No, I meant in which country? This is, for example, a late correction or a third position correction, right? And then, okay, what Alana needs to do is go back into the context, recognize that it did a mistake, repair that, and then continue with the right response. Another example of how we repair that, right? For example, if the user says, drive to Erling, pause. oh, sorry, I mean Richmond, right? We first need to identify what the trouble source is, and then actually repair it, and then to say, basically drive to Richmond, completely rewrite that user sentence to something that would make sense, and the downstream model is actually less prone to errors. Similarly, who won the women's tennis tournament? No, I mean the US Open, Papaioannou. That's another trouble source. Then you might have repairs that, as I said, are combined with clarification requests. Who won the women's tennis tournament? Okay, here, as I said, I have a clarification. Which one do you mean? The user needs to specify which one, the US Open. Okay, now I have all the information I need. I can provide the response that I require. And an example of late correction, who won the US Open? Alana just misinterprets what the user wants to say, or just assumes what the user wants to say, provides a response. The user says, no, I meant the men's singles, which is the sentence that needs to repair the previous one, and all of this context needs to be combined, and then actually you might have the possible response. So all of this is something that happens all the time in human language. It happens with real-life users, and especially when they interact with natural voice and not with text. Text has its own challenges, by the way, like mistyping things, people starting adding emoticons and smiley faces and stuff like that, which could throw off models very easily. And let's see a few example use cases of all of this. And I'm just running through some of these, but it's a very high level of how these large language models can be used in a more safe way and what we need to consider to use them in the actual industry. So at the moment, I said we are partnering with the Royal National Institute for the Blind in Scotland, and we're working to build conversational AI agent companions that will help users in their everyday tasks, right? The most important bit that we're doing for the past actually several months now is building a companion on their phone that is able to detect, recognize objects, but also help them navigate towards an object. It's not just object detection, right? And another one that project that we're starting soon is to automate their helpline support through conversational AI, right? To provide companionship, to provide mental health help, and all of that. So the application that I mentioned is doing what we call spatial relations inference. What that means is we don't only identify an object, which, it's a technology that's been around for more than a decade now, actually, even more than that. But it places those objects next to things that potentially are more well-known to the users. So, for example, I see a few cups in front of the window. Okay, a blind person could know where the window is or the sink is, for example, and can place it in relation to that. It will be easier to actually fetch it. Or it could be, I see a cup on the counter left of the sink, right? So this spatial information provides a lot of context and information for the user. And although this application right now works for indoors, we were also trying initially for outdoors to see out of the blue how it performed. It performed quite well, right? Okay, I see multiple people in the back and a traffic light in the back right. Actually, I couldn't actually see where the traffic light and the truck were initially. I had to say, oh, okay, yeah, indeed, there is a truck. But again, this was just a joke because it's not supposed to work outside because there are other challenges there in terms of legalities, ethics, like security, all of that. Let's see a very quick demo of this, for example, option detection. I hope it plays.
Where is my bag?
And vibrate as well.
I think I see a bag on the chair and left of the stool.
What color is it?
Looks like it might be black.
Right. similar to as the user moves the phone. And this, by the way, is a very early version. At the moment, we're actually doing a lot of live streaming as well, where you can paint the bounding boxes, and the user doesn't actually have to touch anything; they can just talk to it. But you see, as okay, where is my bag? Beep, beep. Okay, it beeps. I know that it's in that direction, but where exactly? I need a bit more information there. Oh, it's next to the chair. Okay, I can potentially find where the chair is, or next to it, I know that there's a bag. Another example of this is when it comes to text recognition, because sometimes the user might say, where are my beans? Where are my Kellogg's? Right? Because we do that all the time. We refer to objects using our own notions. Usually it could be a brand, or it's my Glenfiddich whiskey, for example, right? So sometimes we need to map those labels into an actual object. So this is a short example of this.
What is written here?
There's some latency here in this.
I think this says, Harriet, what university teaching space feedback survey use your photo QR scan give feedback this teaching Ludoshul.
When was Harriet Watt founded?
And I can follow up actually with question answers based on what the context was. Based on what I see in this image.
Harriet Watt University was founded in 1821 as the School of Arts of Edinburgh.
What is it famous for?
Harriet Watt University is known for its focus on science and engineering, and is one of the 39 old universities in the UK
Blah, 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 blah.
comprising the distinctive second cluster
Right.
of elite universities after Oxbridge.
So you see here a demonstration of how this technology can be used alongside with question answering, for example. That it could be that the user is looking for a can of beans, right? Where's the can of beans? Here it is. What can I cook it with? So basically drawing context and information from the visual scene to ground the conversation at that point onward, right? And this is something also very useful, very naturally occurring. Instead of, okay, I got this information, I'm gonna forget anything that I said about beans. So now the next time that I have to say something, I need to explicitly say that I'm talking about the beans, right? There's no need for that because all of that is in the context of the conversation, including the visual information. So this is use case how that can be used for that. You can get recipes, you can do all sorts of different things. The next version that we're working now actually is also read the QR code and also a particular QR code that is used by BPSP, by blind and partially sighted people, which is like colored as well. It's called Navimap. Another example of applicability of such technology is when it comes to stroke rehabilitation patients. At the moment, we've actually awarded an 8.5 million euros, like from the Europa Horizon 2022 project, collaboration with other universities and companies to create 2 virtual assistants, one for stroke patients, which the users will be able to find information about their condition, for example, about what is in their medical files, what did the doctor said last in their last appointment, right? But also for the medical professionals, the hospitals themselves, where they will be able to search through and comb through the healthcare data using conversation, right? Why were our door-to-needle time last semester lower than the average national, for example? So you see how conversational AI opens up the doors to a lot of these applications. It's not just for specific customers, but any type of user. And this is going to be deployed in hospitals across Europe currently. It's a 4-year project that we started this year. Another one that we already completed was with UNICEF. It was during COVID-19 period, which it's not ended yet, but when it was at its height, to combat misinformation about that, because there were a lot of misinformation and myths around the disease circulating the internet. With Alana technology, we were able to comb through them, not only identify them, but also try to find the source of that, and also to be able to provide a more vetted response that would be whitelisted by UNICEF. Last but not least, we've already completed that project a few years back. It was called the Mummer project, and it was to put Alana in a fully embodied robot called Pepper, this little guy here, probably you've seen it, and to put that in a shopping mall in Finland, in Tampere, where it would engage the user in a helpful and entertaining manner, not just as a glorified information booth, but also to be able to entertain kids and actually be able to show, let's say, if the user says, "Well, where's a coffee shop?" using voice, right? There's a lot of miscommunication, a lot of negotiation that needs to happen there. Okay, first of all, I need to check, can you see the red sign? Okay, I ground that you can see the red sign. If you follow that, can you see that? Okay, there are stairs. Can you take the stairs? Okay, if you can take the stairs, then you can go blah, blah, blah. So basically what a human would do, where it would negotiate with the user to find the best option for the user. So that was Alana was doing with a fully embodied robot. And so it was able to interweave these task goals, as in, help the users, to find the coffee shop, alongside with more social-oriented conversation, like entertaining, say, telling jokes, keeping like chit-chat and stuff like that. All right, I think I'm also slightly out of time, or maybe run it too quickly. So thank you for your attention, and any questions, please fire up.
I think this is very good. I used to work for Miscommunication, more or less like help initiating all this prediction work on there, and it's good to see where it's currently heading into.
It is exciting times, and
so we're currently applying something similar to that to our legal department, where paralegals are actually being encouraged to use something similar to go through all the cases and things like that.
This is something that we're currently actively working on. I didn't have a demo, sadly, to show. It is also in the interest of time. Like what we call closed domain question answering, right? So, for example, ChatGPT and GTP3, all of these are what we call open domain. They're able to talk about everything and anything, which obviously increases the risk of hallucination as well. So in your case, for example, it could be, okay, I don't want to know about Albert Einstein, but I do want to know about my paralegal information that I have stored in my own data sources, right? So take that and allow users or even your personnel ask questions about that, right? You have the use case, for example, at the moment we're building about stroke patients for the Rescue Plus project, where the users are able to specifically ask questions about stroke, right? Try to limit the scope to be able to provide more accurate, more controllable outputs. So yeah, this is a direct application of what it is that we're doing. Else? Okay.
Thank you very much.
Thank you.